All right, so in chapter 2, section 6, it's a little bit more of the same, except we're finding second derivatives and third derivatives. Um, so the first derivative in the previous sections, we've talked about, you know, power rule, product rule, quotient rule, and now chain rule. And so now, once we find the derivative, we can take the derivative again. Um, the big thing is, what are we actually finding when we take the derivative of again? There's a problem down here at the end, the application problem, that talks about our position function, so S of t. Um, and so when you're doing a position function, uh, in the book they talk about creating this equation. So it's always negative 16t squared, then it's plus your initial velocity times t, plus your initial height. So if a brick becomes dislodged from the top of the estate building at a height of 1260 feet and falls to the sidewalk below, the reason why we don't have a middle part here is because there's no initial velocity. Um, but it's always negative 16 that equates, or that comes from the gravitational constant. And again, we're in feet. Um, and then the 1260 is our initial height. So that's just where some of this is coming up. But once you take the derivative of your position function, you get velocity. Once you take the derivative of your velocity, you get acceleration. So they mean something. Also in number 13, they're taking the second derivative and then setting it equal to 0 and solving that equation. And so what you do when you are solving the second derivative for an equation, you find inflection points where the function changes its concavity that we'll talk about more in the next section. So there's purposes of taking additional derivatives that we will continue with in future sections. But like on this one, if I take the derivative of this, I get negative 2x. If I take the derivative again, what's the derivative of negative 2x? Well, it's negative 2. And so the second derivative is negative 2, and that's independent of, whatever you want to plug in here. So on this one, I just got a constant, and so if I plug something into a constant, there's nowhere to plug it into, and I get negative 2. A function like this, they're just asking you to find the third derivative. So the first derivative would be 4x cubed minus 24x. So 4x cubed minus 24x. The next one would be 12x squared minus 24. And then the next one would be 24x. Oh, did I miss something? So the first one is 4x cubed minus 24x squared. Whoops. The next one is 12x squared minus 24x. And the last one would be 24x minus... Oh no, 24x squared, the derivative of that is 48x. Sorry. And then 24x minus 48, which is equivalent to what they had. So you take the first derivative, and then you take the derivative of it, and then you take the derivative of it. So it's just finding multiple derivatives. I'll do a couple of these on the supplement, but we're just finding multiple derivatives.